All right, let's get started. So this is nominally a lesson about chaining fetches and nesting fetches and doing lots of fetches and that kind of stuff. But ultimately, anytime we're talking about this, we're really talking about promises. So when we to get started on this, I want you to brain dump. I want you to Slack me everything that you know about promises, not just fetch, but just promises in general. I just got a message. Was it going to be nothing? Okay, it was Damon doing his thing. I thought someone was going to be like, nothing. That's what I know about promises. Cool. So let's do 3 minutes. Just stream of conscious, everything you know about promises. Go. Another minute. All right, send me what you got. Cool. Kelsey, would you do me a favor and read your answer? It was very good.
Sure. I had that a promise is an object that might produce a value in the future. It has three potential states: fulfilled, rejected, or pending. You can use callbacks, attach those to promises to handle the fulfilled value or rejection. And once the promise is settled, it's then immutable.
Hey, very nice. So let's unpack some of that. So in your answers, about half of you associated promises directly with either fetch or HTTP in particular. Not accurate. Fetches return promises, but past that, that's kind of the end of their relationship. So my favorite definition, my concise definition of a promise is it represents an eventual value. So it's a data type. It's like Boolean, string, object, function, array. It's like any of those things, except what a promise specifically is represents an eventual value. So if I had like is okay equals false, cool. Well, that's false right now. If I had is okay with promise.resolve false, that will eventually be false. That's a promise. So why? Why do we need things to happen eventually? We didn't have to do this shit in Ruby. What's the purpose of a promise?
The internet is slow for some people.
Mm-hmm. It also might be, so some other things that are usually promises, any kind of file system operation. Writing a file, reading a file. So we don't do that a ton in the browser, but that's like bread and butter kind of work in Node. Still JavaScript. So it might take forever to read something out of your file system. It might take forever to write a file to your file system. Same thing with networks. Like in any web app, the network requests are the slowest thing. Your app is as fast as your network requests, basically. Because it's got to go to space and back. Pete's sake. So if we don't have promises, and this is how Ruby works, if we don't have promises, you just wait. It takes a second and a half for your thing to come back. Your app can't do anything for a second and a half then. And by not doing anything, I mean your UI is locked. You can't click on buttons. You can't do anything because it's just hung there waiting for that request to come back. So instead, we have these promises where we can still do our logic, we can still do our calculations based on eventual values that we will have while allowing the rest of the program to keep going. That's a promise. Questions?
Are there any other like notable times where you would be using a promise outside of like fetch requests that we're doing now or file systems like what you're talking about?
Fetch, file systems, encryption and decryption. Those are pretty much always promises because like they take an arbitrary amount of time. They're real rough on your system. Like that's the point of it, is it's like the most aggressive math you can ask your computer to do. That's what makes it so secure. And so if you're using bcrypt with something in JavaScript, those are pretty much always asynchronous operations. Other things, well, let's look it up. Yeah, loading, waiting for something to load. It's usually a promise. Tasks. So do this in the future, like intentionally. You do that with a promise. Seeing animations. Whenever this animation finishes, you can do that with a promise too. Really, any place you're using callbacks, you can use promises. A callback solves the exact same problem. More questions about promises? So we have exactly 2 ways that we can handle promises in JavaScript. Anybody know what they are?
Dot then and async await.
You got it. Then catch and async await. So you could do some async thing dot then dot catch. We can also do await some async thing You can also await it. Note that those have to be in async functions. An async function is just like a regular function, except it has the word async in front of it. That's it. It's the only difference. We could return it like that. These are usually inside of try-catch blocks. That's how we do error handling with those. Anything that's async can break for all kinds of different reasons. So we need to be able to handle what happens when they do break. Those are the 2 ways we can deal with promises. What's cool about them is you can mix and match them. I don't know if that's actually that cool. But since it's the same data type, we just have 2 ways to work with that data type. You can also do things like that. You can await a promise, or you can chain thens. I have a strong preference to the then chains. Questions about this?
Should we be using like dot catch somewhere within our like dot thens on fetch requests like you have there?
Yep, pretty much always. In fact, I think browsers started throwing warnings if you don't do it. What's kind of cool about catches, one of the reasons I think it's so much better than the try catch thing, is you can put them anywhere and it'll catch everything that comes before it. So if I have some big long chain of things I can catch the end. And if any one of these things throws an error, it goes to this catch handler. I can also make specific catch handlers. So this will catch any error in the first two, and this will catch any error in the next two. Kind of cool. Other questions about then chains, async await? Cool. With then chains, one more thing that we got to be aware of. If I do some async thing and I dot then off of it, I take the value that this eventual value resolves to, that's over here, and I can do stuff with it. Let's see. So I could do that. What's the thing that gets passed into this next function going to be?
Calculated thing.
Yep. And we can just keep doing this indefinitely. That's how promise chains work. You'll notice that that wasn't asynchronous. It's my favorite thing about promises. Is that, so if a promise is an eventual value, a synchronous value is also eventually still going to be that value. So we can use them with synchronous stuff also. I think that's pretty badass. One of the other things that we can do with this is that we can do promise chains within promise chains. Works just fine. And if I dot then off of that, I can nest these things, which comes in really handy when we're doing a ton of fetches, because maybe I need to return things, the results of two different fetches. Like that. Just take a second, stare at that one for a while.
So would another result there kind of would it be kind of like calling like another fetch within a dot then, and
There you
then
go.
how would you I'm just trying to think of how you would return both, like whatever you had previous plus whatever that new fetch produced.
This. So
You
this has
just
to do with our favorite
explicitly-
topic in Mod 3.
Closure.
Closure. So another result, well, that was just available. That was what that nested async thing returned. But I can see the very thing I returned through closure. It's in an outside scope. Normally your then chains, each of those thens, those functions in there, they can't see each other. They're at the same level. Since I nested this one, that's available through closure. So that's how I can do them both together. And then the thing that I'm returning out of this is the result of that promise chain, which could see both of those. Aren't closures cool?
I think the indentation, I think I had trouble seeing the indentation of that. last
Yeah,
thing.
it's also not monospaced. Here, let's look at this in a text editor. Oops, not what I wanted to do. Let's make this more concrete. Let's say I had to use this response, something in there to make more fetches. I could do something like that. Parse the response. Do something like that. And then that entire chain will resolve there. I did a nested fetch with something that, based on something that I had before. I got here.
So in this example, some list index 0 has to be a URL.
Yeah, it would, yeah.
Yeah, okay.
And in this particular example, since I'm not doing something with some list in there, I actually don't even need to do it this way. I can just straight chain it. So I could do something like that. That totally works too. Ask me some questions about this madness.
As far as like how often you're fetching,
Mhm.
is it better to like fetch the least amount of as possible, or does that really matter that much?
Sure, great question. So a network request is the most expensive thing you can do in your app. Ergo, you want to do them as infrequently as possible. Unless you can do it in a way that isn't interfering with, where the user isn't waiting. So for example, a really common thing is called prefetching. So I fetch some data, I make it show up on the page, and then I prefetch things that I think the data I think I might need next. And so then when the user needs that data, it's already there. It's magic. So now you've created a snappy user experience.
Is that almost like a form of memoization in that case, since you're kind of writing up information?
You could memoize that. So that would be something like, I request this data, and if I've already loaded it, I get my already loaded one. If I haven't, then I make the network request. Two more tricks I want to show you with that, though, that help make that a little bit more manageable. Really common problem with that caching thing. So I say, give me the data. And I return. So I want to get something from cache if I have it. And if I don't, then I want to make the request. So the wrong way to do this would be something like, if this, let's see, if this dot cached response, if that exists, then return this dot cached response, else return fetch. That would just be that, I guess. Can anybody tell what the problem with this function is? So like nominally be memoized. There is a problem with it. It has to do with who's using it or how they would use it. What's the problem?
Well, there's no way to cache it built in. I guess that's one.
Oh, yeah, I guess that would be, good catch. I did write that wrong. Not what I was looking for, but that would be something like, still has a problem.
You can't have sync and async together?
Well, they're super different data types. If I do this, I get back the object or whatever. If I do this, I'm getting back this promise chain. Can somebody explain to me what the problem with that is?
Oh, is it that you would have trouble you'd have to write two different ways to respond to that data because one's a promise and the other one is an object that you have access to?
Ding, 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 ding. One of these I'm going to have to await or chain off of or whatever, and the other one I'm not. That sucks. That's like defeats the entire purpose of memoization. So what I can do instead is I said that a promise represents an eventual value, and I also said that a synchronous value will also eventually be that value. So we actually have a cool utility built in, a promise.resolve. I can't make this synchronous, but I can make this asynchronous. And so now there's exactly one way to deal with this. So that was the one trick I wanted to teach you. The other one is, let's say I did need to make a ton of little requests. They don't depend on each other, but I need to make a lot of them. Examples would be, if we go to the Pokemon API, and I get back this list of Pokemon. Ah, look at these. For every one of these, I get back the name of it, but then a URL where I can get more info. So if I wanted to get all of the like pictures for each of the Pokemon, if I'm chaining that, then I make this first request to get this list, and then I need to nest 1,050 times. All right, now get Bulbasaur at this URL. Cool, we did that one. Now get Ivysaur at this URL. Now get Venusaur at this URL. Fuck that, man. That's going to take forever. We have a way around that. Let's say I fetch. Actually, we can actually do this one in Node. So first, I don't know if you knew this, fetch is not part of JavaScript. Fetch is actually technically part of the HTML spec. As such, it's not in Node. So we have to patch that in. Y, npm install. There's a few different ways to do it. I'm going to bring in node fetch. I think that's the URL. Yep, cool. So I do this, I parse the response. So I'm going to need to do that a few times. So how about I just make a helper for it? All right, so this results is going to have all my little pokés. So I could say that the URLs for each of these are response.results. That gives me this array. I want all the URLs, so I can map over those and get the URL. All right, so this gives me a bunch of URLs. I need to make requests for each of those. Well, let's make sure this is working. All right, let's give it a shot. Hey, cool. So I have a whole bunch of URLs. I could make these one after the other after the other. Is there a better way? Turns out there is. Promise.all. So what I want to turn all of these URLs into is I want to turn them into fetches. So I'm going to map over each of those. Then I'm going to return fetch URL and then parse the response. This hasn't executed any of the fetches, mind you. It's just turned my array of URLs into an array of promises. To execute all of those, promise.all. Promise.all accepts an array of promises and then does all of them at the same time. And then check this out. Wait for it, and there they are. If I wanted something that wasn't even on that original thing, like maybe just the URLs for their sprites. Sprite, front default. Yeah. Sprites dot front default. Cool. I could do something like there they are. Pretty fucking cool.
Is it more efficient to run all of those promises that way than it is to run them in sequence?
Oh God, yes.
That's just blew my mind. I turned in for 5 seconds and I saw promise.all and I'm like, whoa.
There you go. Yeah, if I'm doing those one after the other, it's not fast. So each one of those requests is probably, I don't know, about a second to run or so. So if I'm doing those in sequence and I'm doing all 1050 of them, well, that's going to take 17 minutes to get all of them back. That doesn't work. Let's see if it'll let me get all of them at the same time. Cool, that worked. So if I try to do all 1,000 Pokemon, let's see if it'll let me. Sure beats 17 minutes. Wasn't fast, but got them all. So that was whatever, 10 seconds maybe? 10 seconds, but I made over 1,000 fetch requests.
You have to worry about being like flagged as a bot if you do more in parallel.
Not anymore. But yeah, if I kept doing this a couple of times, they're probably going to shut down my IP address.
How would you do it if you wanted to like maybe only display like X amount per page to try to like lessen the load of pulling like everything onto one? Like if you want to do like 10 per page and like you could do like 10 on the first one, then 10 on the next one.
Like that.
Hmm.
So to take a closer look at what they give me back if when you throttle it like that. It gives you another URL you can hit that's going to give you the next 10. So if I run that one instead with this offset 10, so first one there is Bulbasaur. If I run that one, Metapod. That's called.
Would that same address, how would that look to like keep on going like that? Would it just be the same one?
You could save that and through Clojure, you could return it back out of the this chain that you're making. You could save it in local storage. You can do lots of things. Pretty dang cool. Ask me questions about this. This is heavy.
So if you wanted it to not like, if you wanted to bypass like a slow fetch for each item that you're trying to grab, could you just like, could you do the promise.all, grab all of it when the page is loaded and it doesn't show it, but when they interact with it, it's fast?
Ding, 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 ding. Yes, it's exactly what you want to do. So you maybe load up the first 10. And then you could have something like cool, and then once those come back, show them on the page and then ask for all of them. So their network is still going nuts, but they're still able to interact with the page, they're still able to do whatever, and then whenever they end up clicking on an individual one, why, you've loaded it in the background. That's prefetching. And yeah, you could use that memoization thing that we talked about last week to make that so that, cool, if I already have it, then here it is. If whatever, they knew where they were going and they didn't let the whole 10 seconds run for me to load up all those things, not an issue at all. I'll just make the request for that individual one and get it right back. And then I'll load that in my little cache also. That's how you speed that up.
Do most libraries for making HTTP requests, like such as Fetch, have something like promise.all?
Well, no, promises are separate from fetch. Promise.all is for any promise, including what comes out of a fetch.
Right, that makes sense. Do most languages have promises?
No. Promises are a way to handle concurrency. Most languages have a way to handle concurrency. There's a thing in Java called coroutines. It's a similar idea. Threads in Java, same thing. But then you're limited by how many threads you have. With this approach, no limits, baby. That's why it's so much. Anybody who's like, Node is a shit language because it's single-threaded. Garbage. Like that's a feature, not a bug. So yeah, if I had an 8-core processor and I was doing this stuff on threads, cool. I can handle 8 of these at once. I have to wait for those to resolve before I can do the next 8. Stupid. Single threading for life.
What is promise.all returning? Is it like an
Oh
array
man,
or?
that's the best part of all of this. You know what promise.all returns?
An array of all the promises?
That's an array of their results, or at least it eventually will. Promise.all returns a promise. That will eventually be an array of all the results.
Are you able to interact with one return promise that if other ones are still waiting to be resolved in promise.all?
No. You have all of them have to resolve before any of them are available. That's the way promise.all works. There's a thing called
What happens if they resolve to errors? Sorry. What happens if they resolve to like 404s or something like that?
404 isn't an error in a fetch, but it would be an Axios and a variety of other things. In that case, it goes to your catch handler.
Would all of them go? Would all of the ones that went through correctly also go to your fetch hand? Like, you know what I'm saying? Like,
No, you're misunderstanding. The control goes to the catch handler. Not some of it goes to the catch handler and some of it doesn't. This promise is considered failed or rejected.
Right. If any of them get rejected.
Correct.
And that's maybe, is that a downside to it or a good thing? I guess it would depend on the
Good
circle.
thing. I asked for all these things. I didn't get all of these things. So that's a failure.
Right.
Wait, so then would you need to program in a way to handle that failure so it doesn't like crash everything?
You could. I mean, that's literally what a catch is for. Is, whoa, something went wrong. What do you want to do about this? Gives you an opportunity to handle it. You can also, if you didn't want to lose the entire thing, you can put the catch in there instead. So you're still in this scope. You still have those things. You could also do something like, see if promise.race is part of the actual spec. Yep, it is. You can also race it. So how that works is it's like promise.all, except it will go off of, the first one that resolves, that ends up being the result. So you could do this one if I have 2 APIs and I just want the faster one. But I'll take either of them. If one of them's down, I don't give a shit. I just need one of them. Promise.race will let you handle it that way. Yeah, promise.all is all or nothing. "99 times out of 100, though, it's not going to be the case that you want, I asked for 1050 Pokemon, but if I only get 1049 of them, that's okay. That's pretty rare. Most of the time, you would want it to fail if any part of it failed. More questions?
I'm curious, like, so let's say you were fetching from your Poke API,
Yep.
and then you also wanted to fetch your users from whatever. Would you want to tag these two fetches into the same thing so that it eventually just gives you back both of your responses together? Or would you want to try to call them separately?
So it depends. If better question might be to reverse that. So if I ask for my user and my user has a bunch of saved Pokemon IDs, and then I want to go get those Pokemon IDs, that would make more sense as some sort of chained operation, nested really. I want to get my user back and then take user.pokemon and get all those Pokemon back. That's pretty normal. So that would look something like, so I could do something like that to get their IDs and then turn those into fetches. So I do something like that and then return promise.all. So then it's going to ask for all of those Pokemon objects. And then what I get back are all of my favorite things. This would be pretty dope. More questions about the wild world of promises and fetches.
So if you had all the data load in on like when the website loads, like on load, do you, if it, to prevent like when people have slow internet, would you make like a loading screen?
Good. Depends. There's a couple patterns for this. Skeleton, I think, is the most popular. So this is a UX question, but we actually talked about it a lot on the podcast before. Skeletons probably produce the best results. So let's take a look at the skeleton. This. So when you load up a page and you see this outline of content, that's a loading screen. But what it does is it cues you into where the content is going to be, so you still end up saving the user time. Come on. You could even say that that thing I was just looking at, that's a skeleton screen too. Because as this placeholder, I know that content is going to be there. Oh, this drive one's perfect. So you have these and you usually see like some animation on it that indicates that action is taking place. That's preferable to just having a generic spinner. So you can see this, especially if you can also still take some action on the things that have loaded. That's the nice way to do it.
So how do you code that? Like, where do you put that?
By the way, if you ever have any question about like the efficacy of any particular pattern, NNGs, that's the go-to. And this was their conclusion on those. The way you would code that is that you hard code in what those little things are, animate them with CSS or whatever. And then as soon as your actual request completes, you tear those out of the DOM, put the actual content in.
Wait,
What kind of?
Oh,
Go
sorry.
ahead, Sydney. You go ahead. Mine's off topic.
Oh, I was just gonna ask, would you connect that with like an add event listener?
Yeah, you could. So event listeners are all callback based. This does the same thing. And so if I had something like, and this, as soon as the page loaded synchronously, put all those like little skeleton animations in there. Should be something like that. Maybe better to do it the other way around, actually.
What is the event that people use for page scrolling to trigger fetch calls for more content?
Ooh, that's a great question. Scroll. So what you can do is you have the current position on the page. That's just a global variable, window.scrollY. You can also like measure how far from the top you are in pixels. You can do a bunch of things to see how far down the page you are. You can also see whether or not a particular element is visible. So like element is visible. Oh, there's a newer one for this. jQuery. Oh, this is all like whether or not it's being hidden. This will work better. If you can get a particular element and then see whether or not its offset is less than 0. I actually did this on my page a little bit on kylecorley.com. When you get down to my like resume and stuff, it like explodes out of the screen. It's doing that off of scrolls. That thing there. So the scroll on that one was this is it. This is all the code that makes that thing work. There we go. That's what I did. Get bounding client rectangle top. So on each scroll, I check the position. If that is within my scroll, then I trigger the animation, which makes all those things poof out.
Nice.
Other questions?
At what point do you start to kind of hit limitations when you're nesting fetches? Or is there like an ideal amount, like don't do more than 5 or whatever?
Your browsers are not like Node. Browsers will only let you do 6 at once. So like you're limited there. That's
Wait, 6 layers deep, or are you talking about like creating 6 fetches at the same time?
You can have 6 active network requests in your browser on a tab.
So that whole promise.all thing won't work in your browser.
No, it'll work. It'll only let you do 6 at a time.
Gotcha.
And then as soon as one resolves, it'll do the next one.
Gotcha. Okay.
That's going to change in the future. It's one of the things that HTTP 2 gets around. But HTTP 1.1, it's browser specific, but I think it's 6 in all of them. There you go. And yeah, this is only 1.1. HTTP 2 works completely differently. It's not coded any differently, but HTTP 2 uses a thing called multiplexing, which it's complicated. It takes all of those things and sort of weaves them together. What else?
Thanks, Kyle.
Cheers, baby. Hope that was helpful.
Yeah, thanks. Yeah, it was great. Thanks.
Excellent. Cheers.